According to ESAC, the last 4 decades of extreme meteorological events like droughts and wildfires have more than doubled, and water-related events have become 4 times more frequent. Moreover, the recent unfortunate disasters in Europe and around the world highlighted the necessity to adopt new, innovative technologies to cope with emergencies coming from extreme weather phenomena like floods, forest fires, and heat waves. These 3 disasters are the exact crisis management scenarios that beAWARE aims to tackle. Funded by the European Commission, beAWARE's ambition is to help the emergency services manage major crises more effectively and more efficiently. More specifically, the beAWARE project proposes an integrated solution to support forecasting and early warnings, transmission of the emergency data, aggregated analysis of data coming from the first responders, sensor networks, and meteorological stations, extraction of critical information from social media, visual context analysis during emergency calls, multilingual speech and written communication analysis, report generation from aggregated emergency data, the overall operation of a main public safety answering point, PSAP. beAWARE is a use case-driven project that aims to cover the functionality required by 3 relevant operational scenarios: flood, fire, heatwave. In order to demonstrate, in short, the capabilities of the platform, it follows a capturing of the system functionality throughout the sequential steps of a simulated event that revive the historical Great Flood of November 2010, when the Vicenza city centre, a very busy residential and commercial area, was submerged. During the pre-emergency phase, a cloud-based solution is storing, analysing and delivering dynamic flood forecasting and risk mapping based on the most recent available weather forecast. The Crisis Classification module acquires this forecasting data to classify the crisis level and provides early warnings to the system. After receiving on the Command and Control screen, PSAP, the indication of a forecasted crisis event, the decision maker notifies the public sending of a public alert. Public alert functionality allows the authorities to warn the public and first responders about hazards before or during an emergency by sending notifications on their mobile devices. By sending this alert, the authority upgrades the level of emergency. Simultaneously, the real-time monitoring and risk assessment layer is activated, assessing the evolution of the flood by estimating the overall crisis level and the severity of the ongoing event. beAWARE's system starts collecting and combining heterogeneous data from several resources, such as social networks, visual and audio input from rescuers and people in danger. Specifically, the visual analysis model analyzes the visual content to extract conceptual information regarding the incident. The automatic speech recognition component selects the appropriate language model to generate transcriptions. The social media analysis module continuously crawls through social media content and classifies the posts as relevant or irrelevant. All this data is integrated into the system, where the beAWARE semantic reasoning process clusters and translates it into multilingual natural language reports, and finally forwards them to the PSAP to inform the authorities and decision makers of the progress of the flood crisis event. The same functionalities of the beAWARE platform can be used in other weather-related events, such as wildfire and heat waves. Overall, the beAWARE platform offers PSAP environment, where the data for the specific stations are presented on the map and in the relevant PSAP tabs with all the explanations. PSAP dashboard, where all the data from the crisis classification, such as predicted water level measurements and category, is presented in the relevant graphs. Mobile application that will allow the authority to send a public alert message to all beAWARE mobile app users, and at the same time let the citizens update the PSAP with real-time photos and videos. Sensor Thing Server that uses data from water sensors installed in all the river sections, providing a tool to seek historical data and display all the available measurements. In order to develop these scientific and technological objectives, beAWARE consists of 10 organizations from 7 different European countries, a 3-year project. For more information, visit our website beaware-project.eu and subscribe to our newsletter or follow our social media accounts on Facebook, Twitter and LinkedIn to stay beAWARE on the latest developments of our project.